All right, everybody. Hello and welcome to another physics video lecture. Today we are going to be talking about kinetic energy, all right? In order to understand kinetic energy, we have to go back and remember something called the law of conservation of energy, all right? Now, to conserve means to protect something or to save it, all right? You can think of a wildlife conservation area as an area where you're trying to protect and save the wildlife that lives there. When we talk about the conservation of energy, what we're actually saying is that energy is always conserved, okay? It's always protected, it's always saved. What does that mean? It means that energy can never, under any circumstances, ever be can never be created or destroyed. It can be transformed into a different type of energy, all right? So the total amount of energy that exists is always going to be the same, okay? We can never create energy. Even when we quote unquote make electricity, we're not making electricity, we're converting one form of energy into electricity. Or when you burn something, you're not destroying energy, you're transforming that energy into a different type of energy. So here we see as this crane picks up this steel beam, okay, it's doing work on this beam, and that work is being converted. Okay, it's being converted into an energy that's being stored as the beam is above the ground. We have a name for that type of energy. We call that potential energy. Okay, it's stored energy. In this case, we're talking about gravitational potential energy. And that happens when we pick things up off the ground or when we climb up flights of stairs, all right? This is energy that is stored and that's able to be converted into a different type of energy. Now, our equation for this is the potential energy equals the mass of the object times little g, okay? That's the acceleration due to gravity, 9.8 meters per second squared, times the height, okay? As the mass of the object gets bigger, the potential energy gets bigger. As the height of the object increases, the potential energy gets bigger. They're both directly related. Little g always stays the same. It's always 9.8. The unit that we use for potential energy is the joule. That's the unit that we use for all forms of energy, okay? Now, the question is if we're storing this energy, okay, as the pizza guy runs up the flight of stairs, or as I do work to pick this water bottle up, what am I storing that energy as? What kind of energy are we storing, okay? And we're gonna answer that question in just a second. Forgot about this one right here, okay? To answer that question, let's look at a roller coaster, okay? Now this roller coaster is at its highest point, and it's full of potential energy, all right? It's really high off the ground, all right? Now what happens as that roller coaster comes down the hill? Of these choices, is its energy lost? Does its energy not change? Or is it converted into a new type of energy? If you said C, you were correct, okay? As the roller coaster goes down the hill, its energy is converted, all right? The same way as we pick up this water bottle, okay, we store that energy, and then we can convert it when we let it go, or when the roller coaster goes down the hill. And we convert it into kinetic energy, all right? So here we see that kinetic energy is the energy of motion. It's the energy of movement, all right? So any object that is in motion, any object that is moving has kinetic energy, all right? Similarly, if your velocity is 0, you're not moving, and you have no kinetic energy, all right? And we see this in our equation for kinetic energy, okay? Kinetic energy is equal to 1/2 times the mass of the object times the velocity of the object squared, all right? And this is pretty straightforward. It looks complicated, but what this is telling me is, look, every object has mass, right? And we see that mass and kinetic energy are directly related. The bigger the object, the more kinetic energy it has. But we see that even more important is the velocity, right? The velocity is squared. This has a much bigger role, okay? If we double the mass, we double the kinetic energy. if we double the velocity because of that square, it's not just doubled, it's doubled squared, which is multiplied times 4. Okay? So as long as we have a velocity, we have kinetic energy. The unit for kinetic energy is joules. Joules is the unit for all energy. Remember, energy is energy. There's just different types. Okay? There's different forms. It can be stored in potential energy, or it can be pushing something forward in motion and have kinetic energy. All right? So let's look at this ball rolling down the hill. All right? So I want to know, where does the ball have the greatest potential energy? Well, the only thing we care about with potential energy, right? Potential energy, if we look at our two equations here, potential energy equals mass times little g times height. Little g doesn't change. The mass of the ball doesn't change. So all we care about is the height. So where is the ball the highest off the ground? Did you say A? You'd be correct. Very good. So A has the greatest potential energy because it has the greatest height. Where does the ball have the least potential energy? Well, that would be where its height is the lowest, because again, the mass of the ball does not change, and little g never changes. It's always 9.8 meters per second squared on Earth. So where does the ball have the least amount of height? Did you say D? If you did, you'd be correct. D is where it is the lowest, right? So it has the least potential energy. It's right on the ground. Now let's look at kinetic energy. So we know kinetic energy is equal to 1/2 times the mass times the velocity squared. Now 1/2, that's a constant, that doesn't change. Again, the mass of the ball doesn't change as it's rolling. So the only thing that does change is the velocity, and it's direct. So where does the ball have the fastest velocity? Where is it going the fastest? Did you say D? If you did, you were correct. Some of you might be saying, well, why isn't it G? Here's why. Look what the ball does. As it's rolling down, it goes from not moving, speeding up, speeding up, speeding up, speeding up, speeding up, speeding up, it's going its fastest. Now it's going uphill, it's slowing down, slowing down, slowing down, stopping. So D is where it's moving the fastest. Where does the ball have the least kinetic energy? All right. Well, it has the least kinetic energy where it has the least velocity. Like I just told you, it has 0 velocity at A and 0 velocity at G. Notice that where it has the most potential energy, it has the least kinetic energy, and where it has the least potential energy, it has the most kinetic energy. That's because they're getting turned into one another. They're transforming. We're going to talk more about that next class. But for right now, just remember, if you're high off the ground, you got a lot of potential energy. If you're going really fast, you got a lot of kinetic energy. Okay, so now that we've seen that, let's look at a couple examples. We're going to go through 3 problems, okay? We got 3 variables, so we're going to see how to solve for each of them. Number 1, we got a nice big old dog. It's a Great Pyrenees. It's like my girl Duchess. I love them. Let's look at this dog. We got a 48 kilogram dog. Let's write that down. So first thing we know is our mass is 48 kilograms. Boom. Is running at a velocity of 12 meters per second. Off to a good start. Our velocity is 12 meters per second. How much kinetic energy does it have? KE. Remember, always make a chart. Now that we have a chart, the next thing that we do is write down our equation. We just saw that kinetic energy equals 1/2 times mass times velocity squared. And now we just plug our numbers in. KE is what we're looking for. So kinetic energy equals 1/2, okay? And I always like to write 1/2 instead of as 1/2 as 0.5. 1/2 and 0.5 are the same thing, and this is much easier to put into a calculator. We're going to multiply that by our mass, which is 48, and we're going to multiply that by our velocity, which is 12 squared. Boom. So we have 0.5 times 48 times 12 squared. What we got to do now, let me see if I have this queued up. I should have my calculator right here. So we just put this in the calculator. So we have 0.5, oops, they're wrong. 0.5 times 48 times our velocity, which is 12 squared. And here's the squared. You can't see it because it's behind that V. I hit enter. And I get my answer, which is off screen. No. Did I clear it? Wow, where's my answer? Answer. There you go. Oh, I see what I did there. Okay, bring this down a little bit so you can see that. There it is. And the answer is exactly 3,456, which I think is fun. Maybe this is just the nerd in me, but the answer to this, the kinetic energy, is equal to 3,456 joules, or 3,456. It's a bad nerd joke. All right, so finding just the kinetic energy is easy. You multiply 0.5, which is 1/2, times the mass, times the velocity squared. Simple? Simple. All right, so hopefully you got that one. For number 2, I'm going to show you a new problem. Again, pause the video. Don't forget to write these down as we're doing them, and don't forget to pause the video and try to solve them yourselves. So here's number 2. Go ahead and pause the video and see if you can solve this. You're back, you have an answer, let's see what you got. All right, we got a skydiver falling at 50 meters per second, so that's my velocity. Velocity is 15 meters per second. And he has a kinetic energy, or she, I'm not sure, of 75,000 joules. What is the mass of the skydiver? So mass is what we're looking for. All right, let's write down our equation. Same equation, kinetic energy, 1/2 times mass times velocity squared. Okay, let us plug in our numbers. This time we know the kinetic energy is 75,000. That equals 0.5, which again is the same as 1/2. 1 divided by 2 gives us 0.5, and this is easier to put in your calculator. Times our mass, which is I don't know, times our velocity, which is 50 squared. All right, so I'm going to circle this one. We want this mass by itself, and this may seem tricky, but this is not tricky. All we have to do is do our regular, whenever you have numbers that just need to be multiplied, just go ahead. If you have exponents, if you got a number there, do the regular math. So what we really have here is this. 75,000 is equal to 0.5 times 50 squared times m. And again, we're trying to get this mass by itself. So what we're going to do is we're going to do this math first. 0.5 times 50 squared. So again, we go down here. Oh, one. Go. Okay, so let me clear this. All right, so I have 0.5 times 50, a to the b, and our answer there is 1,250. So now what I have is I have 75,000 equals 1,250 times m. Doesn't this look a lot easier? Because I'm trying to get the mass by itself. That looks like a 6. That's a 0. All right. So I'm trying to get the mass by itself. Still, I need to get rid of this 1,250. This is multiplication, so I do the opposite of multiplying, which is dividing. So I divide by 1,250. Whatever I do to that side, I got to do this side. 1,250 divided by 1,250 is 1. 75,000 divided by 1,250 is, well, let's see. Oops, 0. 75,000. You can actually type these in, it's a little faster, but I'm showing you how to do it on the full calculator. Is equal to 60. That's our answer. 75,000 divided by 1,250 is 60. So that's our answer. Our mass here is equal to 60, and it's a mass, so we measure it in kilograms. It's a 60 kilogram person, about 130 pounds. Good? Did you get 60? Good job. Again, if you didn't, write these down. Pause the video. Okay, make sure you copy these down and put the numbers in the calculator so you know how to get the right answer. All right. Here we have a cat. It's running. Let's see how fast it's running. All right. We have a 20 kilogram cat. Kilograms is my mass. It has 4,000 joules of kinetic energy. KE is equal to 4,000 joules. I want to know what its velocity is. It says, how fast is the cat moving? So now we're looking for velocity. This is the trickiest one of the three, but it's not that hard, okay? I'm going to show you how to do this. So again, we write down our equation. Kinetic energy is equal to 1/2 times mass times the velocity squared. You plug in your numbers. Kinetic energy is 4,000. That's equal to 1/2, which I like putting as 0.5, times the mass, which is 20, times the velocity squared. Now again, we are trying to get the velocity by itself. We want this by itself. So the first thing we need to do is multiply 0.5 by 20. And I can just tell you that 0.5 times 20 is equal to 10. Bring everything else down. Bring down the 4,000, bring down the v squared. 20 divided by 1/2 is 10, right? You got 20 bucks, you split it in half, you got 10 bucks. Okay, so we're still trying to get the v by itself. So what do we need to do next? Well, we got to move this 10. So what we're going to do is we are going to divide, right? This is multiplication. If you don't see that, this is multiplying. So we're going to divide both sides by 10. Whatever I do to this side, I have to do to this side. 10 divided by 10 is 1. 4,000 divided by 10, you just cross off the zeros, and you get 400. 4,000 divided by 10 is 400, and that equals, what do we have left over here? V squared. Now this is our step that makes this a little tricky, but we've seen this before. Here, we're trying to get v by itself, and it's squared, so we have to do the opposite. What's the opposite of squaring something? Did you say square root? And you would be correct. I take the square root of v squared. I take the square root of 400. We go to our calculator so I can show you how to make sure we know how to do this. Clear all. What you're going to do is you're going to hit this button right here. Oh, it's hard to see. Oh, it's this button. I'm going to get rid of this for a second. Very important you can see that. It looks like this, right? It's this little, I don't even know what it looks like. A check mark kind of, but it's that button right there. And we're going to put in 400. Okay, and the square root of 400, okay, is 20. 20 times 20 is 400. Okay, so I know I kind of erased some of this stuff, but hopefully you had this written down. I'll fill it back in for you. Times velocity squared. Here I had 10 v squared, and we divided that by 10. Okay. Good. So I took the square root of v and the square root of 400. Okay. The square root of v is v, and the square root of 400 was 20. This is the velocity. So this cat is going 20 meters per second. And for today, this is everything that you need to know. Okay. Now you know what kinetic energy is. It's the energy of motion. You know where you have the most kinetic energy. You have the most kinetic energy on the bottom of the hill, the least kinetic energy on the top of the hill. And now you can solve for mass, kinetic energy, and velocity. All right? Copy down the notes, send me a picture, earn your extra credit, and use these notes and these examples to crush your DOL. All right? If you guys got any questions, you can always email me or find me at tutoring. Other than that, have a great day.